one, for example, is 200 floor. Let's say 100 floor. When you speak about 1 floor only, let's say 10 floors, whatever. So instead of this one, if we just apply force over there, gonna bend. To decrease the bend, just make one arm here, and connect this arm with the column. We're connecting our core or our shear wall with the columns into shear walls. If we connect with another shear walls, it's not outrigger. So it's called outrigger. Just to connect the body or the body of the resistance, which is a core wall, by outer column. One column over there to carry tension, and the other to carry compression. Okay, one great mistake. Say actually, okay, we're gonna carry tension. Column can't carry tension. There's a problem over there. How can I carry tension? No, don't be angry. Don't be worried. Don't be concerned. Why? Because the column already carried the compression from the load of the floor itself. You're gonna decrease the load. You're gonna serve the column. The column gonna tell you, thank you. You have just rescued with a lot of loads. Okay? So that's called outrigger. What's outrigger actually? You have your internal core or inner core, and you have your outer column. Connect them together at a certain floor. Which certain floor? Should be the upper floor? No, not gonna be outer floor. Upper floor gonna be the worst choice. The good choice is to keep your outrigger here in the middle. If you have one outrigger, one set of outrigger, just keep here. Don't keep there. Keep here. If you have two sets of outriggers, just divide your building in 3 portions and keep the outrigger in the first 2 portions and neglect the other one. Don't put the most upper floor. Why? Because we just calculate drift everywhere, and when we come up with the drift, if you just put here, it's gonna be the minimum drift. Okay? Is the question is something?
What's the dimension of outrigger?
The one gonna be 1 floor, gonna be 2 floors. We have to calculate shear force and moment. I'm gonna tell you how, even if you have a big force, how to do right now. But for example, calculate the shear force, calculate what's required. It's gonna be huge. So it requires almost 1 floor. The one gonna be 1 floor, almost 1 floor, or 2 floors, sometimes 3 floors. I have done 1 tower, 3 floors. This one.
I mean, it's a slab, yeah.
It's not a slab. It's vertical. Like a shear wall, but it's not continuous. It's like a spandrel beam. But spandrel beam only for one small 1.2 meter, for example. The one is almost 9 meter, or 3 meter, or 6 meter. Multiply the floors. 1 floor, 2 floors, 3 floors. It's called outrigger. Outrigger. زراعة الإمداد بالعربي. Outrigger, okay? So we have the outrigger over there. It's gonna be like a shear wall. Some people, okay, this one outrigger, this one is not continuous over there. Come on, guy. It's not carrying shear wall. It's not carrying moment. So it's not the type of quick story. It's carrying the moment in the other direction. It's not carrying a shear. It's not shear anymore. Okay, so outrigger, outrigger. What should we do here? We have our core, internal core. We have our column. Can we connect this one internal core with our outer column, outer hull? We have to make full use of this system. Can we? Yes. What I have done? I have just connect my internal big core with another column, external column. Look, I have here outrigger. The one core for all the building. But one only for 1 floor. Let's say if we have 100 floor, I have 50 floor right now. The one. So connecting the core to 1 column, the adjacent column. So it's called what? Partial staying out the core, the one, with internal core or inner core with outrigger everywhere. The one is like an outrigger. Outrigger shouldn't be concrete only. It can be steel, like the one. It can be berendil, even concrete. Outrigger. Okay. So, but let's say we have just make use of only 1, 2, 3, 4, 8 columns only. Why shouldn't we make full use of columns? The column. We have lots of columns. Why don't we make full use of them? We're gonna make full use of them. How can we? Very simple, by just making outer paired over there. So we're gonna have outrigger over there, of course, but so I'm not connected to 1 column only. I'm gonna be connected to column via an outer rigger bed. It's outer rigger bed, the same like the outrigger. Outrigger, for example, 1 floor, so it's gonna be 1 floor. So it's a huge structure, and the one had been adopted by a lot of towers. Almost a lot of towers in the tallest tower in the world has been adopted or have been adopted the one. Okay? So for example, this one, the AT antique tower in America, the one big tower. What was there? They have outrigger here. There is no outrigger here. This one only for something else for the shear. But we have outrigger everywhere, you know. Just decrease in the drift. It helps too much in drift. But sometimes we have to make opening in our trigger. I have to make a hole over there. I have to make a door. Because I'm not gonna close everything. How can I do it? When I make an opening over there, I have 2 problems. Problem in shear and problem in moment. Correct? How can I solve moment problem? How can I solve the shear problem? For the shear problem, for the moment problem, Very simple, because here I have like compression zone, the moment it's gonna make compression tension, two flanges. I have here big compression, it's gonna be 1.2 meter or more. And what about compression? There's nothing in compression. So I'm gonna make here a slab itself, it's gonna work as a tension member. But slab not gonna be 20, okay, 20 here, but I'm gonna make a portion of it, for example, 60 centimeter, 8 centimeter. A big portion, I'm gonna take a part of the slab and make it as a tension member and increase the amount of reinforcement in the one for tension. Another one gonna carry compression. So I have release of force, like this one section. You have a compression here and tension over there. Clear? Okay. But still I have problem in shear. So at the moment, shear is still a problem. Yeah, I can do something. I can do here something called a steel plate. A steel plate actually, it's not gonna be carrying something called compression shear. The shear does make something called tension diagonal and compression diagonal. Tension diagonal can do as much reinforcement as it can, but compression gonna make a problem in concrete. But steel doesn't have the same thing. We can make here steel plate. Or as it has been done in Kingdom Tower, the one which is gonna be the tallest in Jeddah, they make what stratum tie method. Stratum tie gonna solve the shear problem and okay. So but still we have a big amount of shear. Steel plate is fine. Steel plate is fine, but we still have a lot of shear. What should we do? We have another actually smart solution. What is called smart solution? Smart solution means a good solution. Okay, so something called postponed outrigger casting. Why? The column here will have another reaction from the upper column for example 20 or 40 or 100 floors. It's gonna make all shear, the shear gonna come here and here. Which one is the most stiffness? Maybe the one. So it's gonna come here with the ratio and another ratio over there. Maybe this one gonna be critical. So what you do? Okay, during construction, just consider the column, consider the upper column, and keep one postponed to after you finish everything. So the shear from the vertical load will go directly from there to there. And after everything constructed, just keep one postponed one and construct one right there. You have released the shear right now. Outrigger. Yeah, it can be Brandil, as I told you, it can be Brandil. The one, Shanghai Financial Tower in China. Outrigger everywhere, look here. It's just something that over there. So it's all outrigger. Outrigger with internal core, I have told you, is a magic solution. We have here, I will start over there, it's the WFC, the one. The outrigger here is something which is like elegant. Look, just make some, let's say, brackets over there. It's not outrigger. Outrigger is bracket over there. And we have outrigger pelt, which is truss. And by the way, we have here a mega column. Mega column is, look, 5.45 meter column, the one and one, and it was actually included a lot of I-beams included inside, or steel sections. It was a mega column and silts composite column together. Outrigger is good. Let's say, now I'm structural engineer. I have Burj Khalifa. I want to make structural system for Burj Khalifa. What should I do? How can I say? I know I told you how to just deal with this issue. How can I deal with Burj Khalifa? Very simple. I have outer land over there. I can make outer core over there, or by my system I can just shift my outer core internal like the one. It's gonna be internal. I have internal shear cores everywhere, and just keep the other one and the columns. Burj Khalifa. Okay. Then, but I have problem in torsion. Why? Because the one cannot carry torsion. Torsion is something like what? Like tension from here, tension here, or let's say compression. There is no resistance of torsion. What should I do? I'm gonna make internal core hexagon shape or pentagon or whatever octagon shape to this torsion. And what about internal shear? The shear gonna be here as well. It's gonna be destroyed. Make a flange over there. Make a flange here, flange here. So for Burj Khalifa, for example, what should I do? Just make parallel from every direction. Parallel. Just to this torsion, make one hexagon core. Of course, you're gonna have here some cores, of course, because of surface, stairs, lifts, everything, and make some, let's say, tubers over there, but set walls, and then what? And then you can make full use of what? Because you have already here a tube wall, core, and you have a column, you can make outriggers. Correct? Can I make outrigger? And one actually almost what happened in Burj Khalifa. But Burj Khalifa actually, they don't make offset one panel only. They make more because they want to make more clearer. What had been done in Burj Khalifa, not like the one. It's smaller. but for the one gonna be bigger because of torsion. And the one is that she was just having no. And they have done some outrigger over there. This Burj Khalifa. The one system, just make offset everywhere, make hexagon shape. It's hexagon, but it's not equal sides. Hexagon shape to resist torsion. Make everywhere a shear wall to resist the torsion even for each flange, and connect them by what? By a spandrel beam. Don't think when I say internal core gonna be continuous. No, we have spandrel beam. We say that spandrel beam can make coupled core, correct? Okay. So the one is Burj Khalifa once again. Actually, they have adopted this upper portion called crown to be steel structure. What's steel structure? Burj Khalifa. All of you might see some during construction. Me myself. What the one? Burj Khalifa? No, same thing, but not Burj Khalifa. Find Kingdom Tower in Jeddah. It's being constructed right now. The aim, the Burj Khalifa, for example, now 800 meters something, or 7 something without the crown. Now it's gonna be 1 kilo, 7 meters. And they think Sheikh Mohammed bin Rashid gonna be higher and higher. Because it's like it's competition. Yeah, we're not give it to Saudi Arabia. So look, same system we have here, some offs over there, so one was done by same office, SOM in America. So it's offs everywhere, we have still, what about the torsion? The torsion is making something out of it, make itself as torsion. Itself, it's gonna be here, itself. There is no extension for this one wings. And still same thing here over there, and the one system over there by Revit, and the structure is gonna be like that. Almost like Burj Khalifa. Cheating. Okay, enhancing our trigger gonna be something called Arab outrigger. I'm gonna respond 3 slides, so I'm gonna be next slide, the next lecture about the advanced lateral processing system. But let me just go with what? Now I have come up with a building, I have to make outer core and push out the core. But that guy, Fazlur Rahman Khan, a very honorable man, like him so much, he's in Bangladesh. A Muslim guy. The one guy just promised another system. Also, instead of making partial outer core, I'm gonna make a column. It's based only 1 meter or 2 meters, maximum 1.4 meters. Column, every column. He made like a hull, external hull. It's called the father of towers, Mr. Fazlur Rahman Khan. Even in Bangladesh, if you report, you're gonna have a whole niche university for Fazlur Rahman Khan. The one hull gonna be composed from columns. So this is point. So it's gonna be like the one. You have outer core, not outer core. Tubular structure, called tubular structure. What about internal? You have a core, small core, 20 centimeters, nothing. Just only to carry vertical load. But the main resistance gonna be from the outer only. So it's called tubular structure. Tubular structure. Like a tube. Look, the one's famous, which is WTC, or the center, the same thing. Column. If you just take everything here, the column, like the one. And the one, the Petronas Tower. Yeah. So the Petronas Tower actually is like a tower here. It's like, we can say it's tubular structure. Each one actually was like Islamic star, and just want to make full use of the area, so make here some curves, come up with a shape, and then they bought the structure system. It's gonna be columns based 9 meters, but the column is huge. It's mega column. So it's once again, because it's like a relative. If you just increase the distance, increase the size of column. Okay? So it's one Petronas Tower. Most famous towers, Malaysia, the Mahathir Mohammed, and the one is a tubular structure. Look, some city core in America. You're gonna have here the one which you speak about in mega column. But now I'm gonna speak about the upper portion. That was tubular structure. Column everywhere column here. By the way, the tower actually is the creator of Mr. Mujier was just called as the most honest guy in the world. He's the honest engineer in the world. The engineer was actually giving a lecture to his student, and at the lecture, one guy asked him, what if the wind come from here? What will happen to the tower? What was the problem? Actually, the tower was, the connection between steel connection was a weld connection. Later on, the contractor changed it to be like a volt connection. Mr. Lumigier says, okay, it's going to be fine. But after some time, when his student tell him what if the wind come from quarting, from 45 degrees, what will happen? He postponed the question for 1 week. And he replied that the tower gonna peel. a tower, because if it changes the weld to bolt connection, gonna fail. Because actually the weld can carry force in X direction, Y in the X direction, but bolt not the same thing. Bolt does have some weakest axis. So he purpose that we're gonna make what? Small plate here, 1 feet, almost 2 feet by 2 feet, 6 centimeter by 6 centimeter, everywhere. So it's actually official, or like say it's like offices. They make a plate, it's 5 o'clock p.m. every day they make a plate over there. And alhamdulillah, after finishing this one, only almost 1 or 2 weeks, there was a very big wind over there. If he didn't make this one, gonna collapse. So he was called, he just informed the client, the owner, as I told you, I should tell you right now, if you have a problem in any tower, few towers, please don't hesitate to tell your manager or your client, but in a correct way. Don't tell him I have a problem, tell him I have a problem and I have a solution. Don't keep everything bad. If you just keep everything bad, what will happen? People will be gonna be killed, gonna be criminal, murderer. Haram, it's haram. So what should you do? You should have a session, but just think how to solve the solution, how to give people the solutions. Okay? This one was city core. City core down in America, of course. The one, and then there's the first structure, and what actually changed it to a lot of big column. How it was changed, because actually it was like here at church, which was like from Heritage of America. So it keeps the church over there, and it transferred the whole hull, which is tubular structure, to 4 mega columns. And of course, we have just take something called mass number. We're going to speak about what mass number next time, especially number of mass number. What's the mass numbers? All the form of tubular structure. We have a tubular structure over there. You can make any such tubular structure. Okay, but tubular structure does have a big or a major problem. You have a problem over here. Okay, if tubular structure is very fine, as Rahman had told, so what do you do? Why shouldn't we take tubular structure everywhere? Because we have a big problem called shear lag. What's shear lag? Very simple. What happened? Look, we have, for example, a moment coming from here over there, the earthquake itself or the wind. We will have here resistance. We have here tension, we have a direction compression, we have a tension here, over there, and compression over there. Tension here and compression there. But what about this column? The maximum tension here, what about compression here? It's not going to be straight line. There is no straight line between this point and the point. It's going to be some curve like the one. There is dropping. The shear is not the same. The shear is going to be dropping. A lagging shear. Lag means there is no same shear, no identical shear. Shear is going to be decreased. The maximum or the more distance over there, you're gonna find one 0. So we have a problem with Mr. Fazur Rahman Khan system. If you have outer core, there's no problem, no shear lag. But if you have a lot of column severity and spaced 1.5 meter, you're gonna have what? Shear lag over there. So the same guy, Mr. Rahman Khan, he has proposed a lot of solutions. How can we? We just increase the beam, gonna be deep beam. Don't tell me I'm gonna make a lot of columns over there with small beam and gonna be tubular structure. No, it's not tubular structure. It's a frame. Should be a nerve. Intermittent movement is the frame. If you want to make tubular structure, please keep some of the shear walls, keep some of the core. How can you make some? By decreasing shear lag. How can you make some? By using a deep or spandrel beam. And this one actually was adopted in World Trade Center. But Fazur Rahman Khan is an active guy, not like us, not like me. But he go for another solution. One shear lag has been solved. And what about if we just connect them by bracing? But what I mean, if you just connect by diagonal bracing, all of them gonna work together because they have a bracing. It's called braced tubular structure, done by Fazur Rahman Khan. So tubular structure itself, with its enhancement by Fazur Rahman Khan, once again the braced tube was by Fazur Rahman Khan, and he has adopted this one in one tower called John Hancock Tower in America, of course. Look here, the one.
Concrete.
It can be both. It can be both. For this tower, I don't know if it's concrete or composite, but it can be both. But speaking, this one actually, I'm sorry, this one is steel structure, but it can be both. I'm sure about this one is steel structure. But for concrete, what will happen? It's not going to be straight line. It's going to be like beams, then just like abrupt change, and then abrupt change, and then going on the cone source. That concrete is not going to be smooth like the one. Because we cannot cast like this one. It's going to be like steps. This one is steel. I'm sorry, this one is steel. I'm sure. Okay, so this one, John Hancock in America. But okay, that's good. We have just go with deep beam, we have go with the braced tube. Do we have another solution? The same guy, Fazur Rahman Khan, come up with another solution. What other solution? To make something called bundle the tube. Okay, we have here 1 point and 1 point, and so I'm gonna come down sharply. Please do another one row here. And one root slope gonna increase, it's gonna shifts one up, so we're gonna have a smaller shield leg here, smaller shield leg here. Instead of one curve only, it's gonna be more than shield legs. Small. So he has solved, or he has solved, he has solved. This is the problem by what? By internal ribs. Let's say, or bundle tubes. One tube, they are bundled together, collected together. It's called bundle the tube. And it's what I don't actually in series tower. Series tower is very close. Very common, all of us think, no, there is tower, it's bundle tube series tower. I think ejection has made the movie, famous movie in this one, just climbing the facade. Okay, so even in this one bundle tube, there's a good choice actually. You can remove this portion, you can remove this portion, you can control this structure. Like what happened in Burj Khalifa even, it was partially internal or let's say semi-outer tube wall, but still we can just omit here, omit there. Why we omit? To just resist wind. You have to confuse wind. If you confuse wind, you're going to reduce the wind. In Taipei Tower, they have to reduce the wind 30%. Bundle tube, the one. Series tower is a good example, a role model of, let's say, bundle tube, the one. The other column is very small. Yeah, but still it's bundled. And the ones, another tower over there. Okay, what if you use, for example, now I have outer core. Can I make internal core or internal tube? Yeah, I can do. And once again, by Fazlur Rahman Khan called tube structure. So Fazlur Rahman Khan himself has done tubular structure and braze tube and bundle tube and tube. 4 systems is the father of the towers, of course. Mr. Fazlur Rahman Khan. Look, tube over there. The difference between sun and where it is center, the internal core is not capable to carry any force. So if vertical load, you can do it and relate it in the lateral force. Tube. Like what? Like the one, which is type A, 101, type A 100 because it's 100 floor, type A in Taiwan. Type A actually is the very famous and very common tower, which is almost it's 1.1 meter floors. The good thing in type A, as you have, or you might say this is here rough edge, it's not smooth edge, but it was like this rectangle. Then the RDWI is a company which is for wind tunnel. They just tell them to just make hunches or let's say notches over there. To make it instead of sharp angle to be 3 steps or something. They have to decrease the wind, as I have told you, to 70%. From 100%, 30% was cut out. So by that one, that's one. Actually, and one good thing here is something called mass number, and then speak about mass number in the next lecture, And they have outrigger over there. This one is steel structure or steel structure, but this one is the internal core. This one what I'm pointing now. Like say core and core or tube, and you have outer belt over there, and you have outrigger everywhere. It's very huge, and you still have what mass number over there. We're gonna speak about mass number next time, but still the one is a very intelligent. You know, during the construction of this tower, actually, what was happened actually, there was an earthquake, huge earthquake in Taiwan. What happened? Almost all the Egyptian tower was damaged, partially damaged. Only the tower was very good because of its number. And only slight because it was during construction. Some shuttering on the last floor was just damaged, but everything was fine. At this time says the safest place at the earthquake is the top of tower. You know why? Because no one can come with you. You'll be there. No, not like this, of course. Say I'm not using the mic. Okay. So, it's one called tube and tube. Okay, the one tubes, one type A, with different levels. You have here different levels. Type A 1v1. And so, we're going to speak about mass number next lecture. Over there, next lecture, we're going to speak about mass number. And so, it's actually 73 tons. Think about big walls, 73 tons, 730 tons at an upper floor. What will happen? How can we just shift it up? We don't have a tower crane which carry 730. We're going to speak about the next lecture. And the one that which I want to tell you, just they make instead of one angle only, like steps, they decrease the wind, it reduces something good for extending, and decrease the wind 30%. The one system is very important. Actually, it's like as an extension of Mr. Fazlur Rahman Khan, but not done by Mr. Fazlur Rahman Khan, which is called the grid system. What's the grid system? It's very simple. If you have any organic shape, any like ghost shape, okay, what should you do? Just make inclined column next lecture. I mean inclined like that one. Slanting column over there, another slanting over there, and horizontal one. We're gonna make an external hull. Hull means crust, قشرة. Like the egg. You're gonna figure out what's one hull